from it. So hopefully by the end of the class today, we'll come back to free energy. All right, so what is an electrochemical cell? It's any device in which electric current, which is a flow of electrons through a circuit, is either produced by a spontaneous reaction or used to bring about a non-spontaneous reaction. And so a battery is technically a collection of cells in a series so that the voltage that each cell produces is the sum, the battery has the sum of the voltages of each cell. So let's take a look at what some of these might look like. Here's a little cartoon of a simple version. We have a beaker, two beakers with different solutions in them, two electrodes, a salt bridge across, and as electrons transfer through this, you can read a current on an amp meter here. You can read some kind of voltage coming off. And so I like to talk about how good you guys have it at MIT, with the web and handouts and everything, and how students in the old days at MIT, if they're going to do their problem sets at night, first they had to build a battery to get electricity to be able to see. So you guys have it easy. You have these electric lights and all this fancy stuff now here. So let's break apart sort of the components. Here is my beautiful picture that I drew of this system. That's why I show you a better cartoon first. So this is a beaker. Here's one beaker with one solution on this side. Here is the other beaker. So we have two electrodes put in, have a salt bridge, and then we have a wire across where we can measure voltage. So let's think about what is happening on each side. So in one beaker, you're going to have an oxidation reduction, and in the other beaker, you're going to have a reduction. So if we think about what's happening over here, you could have a zinc system is oxidized from zinc 0 to zinc plus 2. And so this is sort of a view of what would be happening at the electrode. You have zinc solid or zinc 0, and you also have zinc plus 2 in solution. And so as you take a zinc solid atom going into a zinc plus 2, you can have an oxidation reaction. And here would be the equation going down. So zinc solid to zinc plus 2 with 2 electrons. Those electrons can go through to our other beaker on this other side. And so here we have a copper solid electrode or cathode in this case, and we have copper plus 2 in solution, which is being reduced to copper solid. And so we're plating onto our electrode on this side. And so here we have the reduction reaction, copper 2 with 2 electrons going to copper solid. So our oxidation is happening at an electrode called the anode. The reduction is happening in an electrode called the cathode. And as these reactions occur, you're changing the charge on either side. So you have this salt bridge. And so to neutralize the change in charge, you would have negative ions come down here because we're producing more plus 2. And on the other side, potassium is going in as we're going from copper plus 2 to copper solid, again, to balance this change in charge that's occurring. So those are the basic components of a simple electrochemical cell. So we could talk about the cell. Here's some nomenclature that represents the cell. So the one that I just showed you, you have one electrode, zinc solid, and we also have zinc plus 2 in solution. You have a single line between the solid and the zinc plus 2 ions in solution. That indicates there's a phase boundary, so you're changing phase from solid to aqueous. Then if you see 2 little lines, that tells you, okay, one part of the reaction's in one beaker, the other part is in the other beaker. That represents the salt bridge, which separates out the 2 half reactions. And then on this side, we're going from copper 2 in solution, single line, which indicates the phase boundary, to copper solid over here. So the amount of charge that goes through the system it depends on how much of the zinc that is consumed or the copper that is deposited is proportional to that charge, the number of electrons that go through the system. And this